Okay, so we have to turn off the lights so that you can actually see the beam inside the tube. It's been a while, so the cathode has warmed up. So the next step is to bring the accelerating voltage up to about 100 volts. And this is it. This is your accelerating voltage, and we bring it to 100 volts, just like that. Should be able to see the 100. Now set the magnetizing current direction switch to clockwise. So this is the switch going clockwise. The red lamp goes on, and bring the current to about 1 ampere. So we already will be able to see an effect in the tube, so let's do that. To 1 ampere, there we go. You see that green beam of electrons that has just appeared, and the current is 1 amp. And you can see the circular motion of electrons. The beam emerges from here and goes all the way around, and you can see how it goes. So our goal is to measure the radius of the beam, and knowing the voltage and the current, we can calculate the magnetic field, and then do the ratio between the charge of an electron and mass of the electron. So let's do that. We have two numbers that are already preset. The first one is the number of turns in the Helmholtz coil, and it's 150 turns, and the radius of Helmholtz coils is 0.140 meters, so 36 figs. The first voltage, I don't know, let's do 150 just to make it brighter. So 150 volts, you can see that. And for the current, let's do a couple amps. Let's do 2 amps. So 2 amps, 150 volts. And the radius is half of the diameter. So starts at, yeah, that should be your point of view. It's about 7.1. And goes all the way to from my perspective, it's about 11.4. So the radius would be the difference between 11.4 and 7.1, and that's in centimeters. Be careful, you have to convert that into meters again. So let's do another one. N is 150, R is 40, The next voltage, let's do some more. Let's do 200. As you can see, 200. Let's change the current. Can't really change it anymore here. I don't want to overload the apparatus. Let's do 1.5 this time. So 1.5. There we go. So 1.5 and 200 for voltage. So the radius here is just like that, 6.2. I know from your perspective it's a little slanted, but it is. You see how you can't really show it with a cell phone that I'm filming. So 6.2, and the other one is something like that, 12.8. So 12.8 take away 6.2. And that's in centimeters, and that was the diameter. So for both of those numbers, this is the diameter. So make sure you divide the difference in half so that you get the radius. So that would be like what? That's 4 centimeters, cut it in half. That would be like 2 centimeters for the radius. And that would be 6 something. So that would be 3 something centimeters for the radius. So once again, this is not the radius. That was the diameter. That was the difference between the left and the right. Point of a circle, so that's the diameter, not the radius. The numbers are for the diameter, not the radius. Be careful. What else? So using the formula that we have here, you calculate the magnetic field first, then you calculate the E to M ratio based on equation number 3. So plug in the value for the magnetic field that you calculate from here. And that's pretty much it for the calculation part. You have to compare it to your accepted truth value. The charge is 1.6 times 10 to the negative 19th, and the mass is 911 and what? 10 to the negative 31st, I believe. Well, anyways, check the data from the textbook and calculate the percent error between the theory and whatever you got from the experiment. Once again, pretty cool lab where you play around with voltage and the current. See how electrons do make a circle, because the current running in the coils creates magnetic field, and magnetic field exerts a magnetic force onto the charged particles. Okay, this is the end of the lab. Let's turn down the voltage, turn down the current. And turn the power